Oh, hello and welcome to a new lecture on statistics, where this time we are going to discuss Bernoulli distributions. So Bernoulli distributions are called after a very famous Swiss mathematician and physicist, Daniel Bernoulli, who lived around the year 1700. And he is actually famous for many results in physics and in mathematics as well. So we saw in one of the previous lectures that a distribution is basically a function that describes the frequencies of the outcomes of a certain or particular random experiment. So in general, a distribution tells us how often, on average, a certain outcome in a random experiment is going to take place. And we saw that if we look at the average result or amount of times that an outcome will take place, so the average amount, then we are pretty close to the concept of probability of a certain outcome to take place. And so the Bernoulli distribution, which is a special case of distributions, is a very special one because it basically just distinguishes between success and no success. So the Bernoulli distributions basically only knows two random variables, so one for success and one for no success. And a Bernoulli distribution can be best visualized by a probability mass function. And in order to illustrate this, we are going to discuss again the random experiment of a flip of a coin. So a coin has on one side tails and on the other side heads. And in the beginning, we are going to consider a fair coin. So basically, we have a 50-50 chance to obtain tails and heads. So the random variables that are associated to this random experiment of flipping a coin one time are x equals 0 for 0-time tails and x equals 1 for 1-time tails. And the associated probabilities, if the fair is supposed to be coin, the coin is supposed to be fair, are 1/2 each. So basically we have 1/2 here and also 1/2 to obtain heads. So of course, if the random variable here is x equals 0 for 0-time tails, that means that we obtain heads because there are only two possibilities. And with this, we are already ready to draw the probability mass function, which is basically a plot that on two axes. So we have a y-axis and we have an x-axis. And on the x-axis, we put the random variables. So x equals 0 and x equals 1. And on the y-axis, we have the associated probabilities. So we have p of x, for p being the probability of the random variable x. And so we have 2 times the probability 1/2, so we are basically somewhere here. And we see that for the random variable x equals 0, we have a probability of 1/2, so we are somewhere here. And for the other result, x equals 1, so 1-time tails, we also have a probability of 1/2. So this is the probability mass function or distribution of a Bernoulli random experiment where we have either a success, no success, so 0-time tails, so not obtaining tails, or success, 1-time tails. And then we can also imagine a very similar situation, a random experiment, but this time we are going to have a coin that is not fair. So one of the outcomes is more likely to take place than the other. So in this case, we will just assume that it is more likely to obtain tails than heads. And we will say that in 70% of the time, we will obtain tails, and 30% of the time only heads. So again, here we have, as we are performing a Bernoulli random experiment, we have 2 random variables. So x equals 0 for 0 times tails or heads, because we saw that basically not obtaining tails means obtaining heads, and we assume this time that the coin is not fair and that tails is more likely to take place, so heads is less likely to take place. And then the associated probability by assumption here is probability of x equals 0 is 3/10, which is equal to 0.3. And then of course the other result is obtaining tails, so x equals 1. so 1 time tails. And here we say that the probability of obtaining tails is then 7/10, or 0.7. So it's important to end up, when we only have two random variables, the sum of the associated probability has always to be 1. And in this particular case, we can also draw the Bernoulli distribution. It will be slightly different. Again, we have the probability mass function, which is a plot in two axes, x and y. And on the y-axis, we still have the probability of the random variable. And on the x-axis, we have the random variable. And here again, we have x equals 0. And the other one is x equals 1. But this time we have different probabilities. We have 3/10 for x equals 0, so we are basically somewhere here. And we have 7/10, so basically somewhere here, for the result of obtaining tails. And this time we see that the probability mass function describes the Bernoulli distribution and has not this symmetric shape like here. And by the way, this kind of distributions, where the results for the two random variables are the same, are called uniform distributions, where this is not a uniform one. But what is important is that the sum of the probabilities end always up at 1, because all the outcomes have to be taken into account and sum up to a total probability of 100%. So that's basically it on Bernoulli distributions. If you have questions, please leave your question or your message in the comment section below. And if you like to see more content like this, then please give my video a like and subscribe to my channel, and see you in the next video.